Okay, so I'm going to give you a clue for the dang smart one. Okay, so before we've got this turntable and a person standing, and evidently they can stand right on the edge of it, and nothing's moving, right? Okay, and this cylinder has a moment of inertia. It's got an axis in the middle here, right? It's got a moment of inertia of 1,700 kilogram meters squared. All right, this is a 55 kilogram person. Okay, this is 6.5 meters, so that's quite a large, right? Okay, now at some point this person is going to be, let's just draw a picture of this again, right? Afterwards, let's draw a picture of him right here. Okay, they are going to be going at 3.8 meters per second with respect to the turntable. And this is what makes it so darn hard, right? Okay, we know that their velocity, they've got some tangential velocity, right? I'll call that v tangential, right? Okay, of the person, or I'll say v of the p, okay? We know that the velocity of the person plus whatever this tangential velocity is of the merry-go-round, we know that that's 3.8 meters per second. That's what it means for them to be moving at 3.8 meters per second with respect to the turntable. Okay? So that's one of the things we know. In fact, that's the only thing we know, right? We also know that the total momentum here is 0, right? So their angular momentum, right, of the person, so the angular momentum of the person, the I omega of the person, is equal to the angular momentum of the turntable, right? It's actually equal but opposite, but you can just set them equal, okay? The angular momentum of the person, the anti-clockwise momentum in this case of the person, is equal to the clockwise, in this case, momentum of the turntable, which of course will be turning like this, right? Well, the turntable's easy, right? It's going to be 1,700 times omega of the turntable, right? The person is, that's interesting, right? They're going to be moving at some velocity, we'll call it velocity of the person, right? Okay. And they have a moment of inertia of mr squared, right? So the person, the L of the person, is going to be mr squared, right? And this is our r, this is our m, right? Mr squared times their velocity, right? The velocity of the person over the radius, right? And I've done an important substitution there. Remember, omega is v over r. Okay? So there, with respect to the Earth, their moment of inertia is mr squared vp over r, right? Okay? That's the moment of inertia. And then this guy is this, right? And then we can do some clever things. Seems like you ought to be able to figure this out, right? Okay, there's the velocity of the person. Isn't this also... this one's 1,700 times whatever that tangential velocity is of the merry-go-round over its radius, right? Okay, so now you've got, what do we got? We got this equation with Vp and Vt. We've got this equation, right? Seems like you can solve a system of equations here. And you can get either Vp or Vt and then find, ultimately, once you find the velocity of the turntable, seems like you ought to be able to figure out the angular velocity, right? Angular velocity will be the turntable's tangential velocity divided by its radius. Is that right? Anyway, that's my clue for you, okay?